I am Madam Gracious Kanzini from Educare, Tanzania. Warmly welcome in our best media, Educare TZ. So as you can proceed with our A-level tutorials. And my student, here we have our chemistry subject and our class level is Form 5. So we are proceeding with inorganic chemistry in our periodic classification. And today, my student, we are going to look on the issue of the nitrogen and oxygen. We are going to look on the issue of nitrogen and oxygen. We're still discussing the issue of the ionization energy. So the decrease in the first ionization energies across the period from nitrogen to oxygen is also observed not to follow the general trend of increasing ionization energy across the period from left to right. Kwa utaona kuna observation ambayo inaonekana hapa kwamba tunapo consider the ionization energy ya nitrogen na oxygen, utakuja kuona kwamba it's observed that not to follow the general trend, hasa high follow the general trend of the increasing ionization energy across the period from left to right. So now how it happened this, we have to study it. Kwamba kuna baadhi ya observations zimeonekana kwamba hazifollow ile trends ambayo inajulikana kwamba across to the period from left to right ionization energy inakuwa hivi. So baadhi ya hizi element utaona kwamba the ionization energy ina display the difference. It tend to display the different trend. That's why anasema kwamba the decrease in the first ionization energy across the period from nitrogen to oxygen is also observed not to follow the general trend of increasing the ionization energy in the period from left to right. So nitrogen consists of the 3 unpaired electron. Sasa kwa nini hii trend yake imeonekana haifollow ile increasing of the what of the ionization energy trend in the periodic table? Kwa nini from left to right? So we have to discuss now the reason why kwenye nitrogen imekuwaje na kwenye oxygen inakuwaje. But you have to remind yourself that when we talk about nitrogen and oxygen, these are elements with the lone pairs. Nitrogen in a lone pair, oxygen in a lone pair. So now let's just discuss about this. So nitrogen consists of 3 unpaired electron in the 2p orbital. Kwamba wakati tunaandika electronic configuration ya nitrogen, you can see that kwenye p orbital there will be unpaired 3 unpaired of electron. Maana kwamba tutakuwa na zile electrons zitakuwa zimefilled moja moja kwenye 2p orbital. Kwamba kwenye 2p orbital pale tuna 3 orbitals. Kwa hiyo tutakuwa na 1 electron which are unpaired one, which is the half filled configuration and therefore stable. Sasa ikishakuwa half filled, my dear, that is stable, ina maintain ile electronic configuration ambayo ni stable. Sasa hii ni sifa nani ya nitrogen. So anasema kwamba to remove an electron from this stable configuration need a higher energy. Sasa hapo ndipo tofauti unapoanzia. Kwa sababu kwenye ile 2p orbital of nitrogen, wakati tunaandika electronic configuration, you can see that it have 3 unpaired electrons. Kwa hiyo sasa ile configuration ina attain stability. Sasa in order to remove the electron there, it is actually difficult because the electronic configuration attain that have filled stability. Kwa hiyo anasema kwamba to remove an electron from this stable configuration need higher energy. Kwa hiyo itahitajika energy kubwa ili uweze ku remove electron there, kwa sababu ile tayari ishakuwa stable. So hence higher ionization energy. Kwa hiyo sasa hii inapelekea ionization kuwa kubwa. So now in the oxygen anasema kwamba the outer 2p orbital consists of 2 unpaired electrons and 1 paired of electrons. Sasa tunapokuja kwenye oxygen, ile outer 2p ina maana ile 2p orbital ya nje inakuwa na 2 unpaired electron. Ina maana kuna electron moja amekuwa filled, lakini kiorbital kimoja au kibox kimoja kina this one paired of electron. Ina maana kuna zile electron mbili afu moja. So now anasema kwamba this configuration is unstable kwa sababu kuna hiyo kiboksi kimoja kipo fulfilled afu ingine moja. Sasa hapo hatuangalii hiyo stability, na maana haijakamilika, kwa sababu ili iwe stable iwe half filled kote au iwe fulfilled kote. Lakini ikiwa ikiwa kwa zile orbital maybe moja ipo paired, nyingine zipo unpaired, maana kwamba ile sio nini, sio stable configuration. Sasa kulingana na oxygen kwenye outer p orbital utaona kwamba there is a 2 electron which is unpaired, but also 1 electron is paired. Therefore you can see that this configuration is unstable. So as it is neither half filled nor full filled, ni unstable kwa sababu unaona ipo ni fulfilled wala yani ni kitu kama haipo fulfilled wala ipo yani haipo fulfilled wala haipo half fulfilled. Kwa hiyo ni unstable configuration. Therefore now it requires less energy to remove an electron due to the lower stability, causing it low fast ionization energy. Sasa kwa sababu hiyo kwa sababu ya hiyo character utaona kwamba wakati wa kuremove zile electron, kwa sababu unaona kwamba it's neither half filled nor full filled, therefore zile electron it will be easy to remove. That's why anasema it requires less energy to remove an electron. Kwa nini? Due to lower stability. Sasa ile stability kwa sababu ni ndogo, pia energy ya kuremove electron itakuwa ni ndogo, therefore causing it lower fast ionization energy. This is for the case of the oxygen. Lakini for the case of nitrogen, you can see it's the difficult kwa sababu kwenye 2p orbital there is a half filled of the electron. Kuna ile 3 unpaired of the electron ambayo ina feed the half filled ambayo ni stable configuration. So that is why the observation of the trend not to follow ile trend ambayo ilikuwa imeonekana hivi. That's the main reason, and this is how you can explain once you are asked about the case of the nitrogen and the oxygen. The case of nitrogen and the oxygen. But also we have to see the case of magnesium and aluminum. Magnesium and the aluminum. So the decrease in the ionization energy across the period is also observed when moving from magnesium to aluminum. Sasa kadri ambavyo tuna move kutoka kwenye magnesium to aluminium. Kumbuka magnesium to aluminium ina maana tunatoka kwenye group number 2 kwenda kwenye group number 3. If you remember MgAl, mgeni aliye, magnesium aluminium, ina maana ni group number 2, group number 3. Sasa hapa utaona magnesium ana 2 valence electron, lakini aluminium ana 3 valence electron. Sasa tunapokuja kwenye issue of the ionization energy, kumbuka tuna ionization energy 1 2 3 4. Sasa huyu magnesium atakuwa anaenda mpaka ionization ya pili, lakini aluminium mpaka ya 3. Sasa anakuja kusema kwamba the decrease in the first ionization energy across the period. Ina maana across the period sasa tunaangalia tunavo move kutoka kwenye magnesium kwenda kwenye aluminium. Also observed that when moving from magnesium to aluminium kuna hii decreasing of the what? First ionization energy. This does not follow the general trend of increasing in ionization energy across the period. Hii nayo pia haifati au haikidhi ile trend ambayo inajulikana kwamba across the period from left to right this ionization energy should increase. Sasa kutakuwa na decreasing. Sasa kwa nini kuna decreasing? Ndio maana tunakuja kusoma hizi expressionality. Tumeona kuhusiana na nitrogen na oxygen. Sasa hivi tuone kuhusiana na magnesium na aluminium. Kwamba tunavyo move kutoka kwenye magnesium kwenda kwenye aluminium, utaona kwamba it is a trend of the ionization energy tend to decrease. Maana yake kwamba haifollow ile trends ambayo tunaijua which is the increasing in the ionization energy across the period. Sasa kwa nini haifollow is now we have to discuss why magnesium ipoje na aluminium ipoje. So after discussing this is where we can get the answer. Kama tulivyoona answer ya nitrogen and oxygen. Kumbe kwa sababu ya nitrogen ana zile 3 unpaired electron, ana attain ile half filled stability. Lakini tunapokuja kwa oxygen yeye ana 2 unpaired and 1 paired electron. Kwa hiyo anakuwa anacheza hapa kwamba neither full filled nor half filled. Therefore actually ndio maana trend yake inakuwa observed in that way na high follow hii the general trends of the increasing in the ionization energy across the period. Sasa how about magnesium and aluminium? Why that this trends imekuwa observed kwamba haifollow pia hii scenario? So we have to look on the reason. So my student, this marks the end of our first discussion. So now we proceed with the second session. Bye bye. Let us see the second session soon.